Hi everyone. We'll start today's session shortly. So, till some more participants join in, could you quickly confirm if I'm audible? You can type a yes in the chat box. Thanks, Pooja, for confirming. Thanks, Asha. Thank you. Just couple more minutes and we'll start today's session. Thanks everyone for confirming. Good evening, everyone, and a very warm welcome to today's webinar, which is AI Agents Unlocked, the learning behind smarter, faster, autonomous systems. So, it's a pleasure to have you all with us today as we delve into one of the most exciting frontiers of artificial intelligence, which is the world of intelligent agents that can learn, adapt, and act on their own. So, in this session, we will explore how AI agents are evolving from simple programmed bots to highly capable autonomous systems that can, make decisions, learn from interactions, and optimize their performance in real time. And to take us through this fascinating topic in a greater detail, we are delighted to have with us our speaker for today, Rushikesh Meherwadi, the Vice President of Data Science at Motilal Oswal. And Rushikesh is an accomplished data scientist with over a decade of experience in performance testing, application monitoring, and Java tuning. His expertise spans across NLP, which is natural language processing, machine learning, and mentoring professionals in the tech industry. Rishikesh is also, passionate about educating the next generation of AI professionals. Having worked with top edtech platforms and corporate giants like Capgemini and Renault Nissan, his vast industry experience combined with his passion for teaching makes him the perfect guide to answer all your questions about this exciting field of AI/ML. So, how can you all participate? Is that? Remember, the session is interactive, so please feel free to drop your questions in the chat or else in the Q&A tab. And our main goal is to make sure you leave today with the information you need to take action and step confidently into the future of AI. And please remember, no question is too big or too small. Ask as many questions as you like. And without further ado, let me invite Rushikesh to take us through today's session. Rushikesh, over to you.
Hey guys, thanks a lot for the introduction. Great to be here. Guys, just quick check. Can you please let me know if you're able to hear me well, loud and clear? Just yeses over the chat would be very helpful. Great. Thanks a lot, guys. Good to see. That's the energy I want over the whole session. This is more of like just me being talking. I want this to be more of an interactive session where we all discuss together rather than me just sharing it. So please be open, ask questions, let's make this more discussion-based session. Great. So a good amount of information is already told about me, but let me just add few pointers on top of what the team mentioned. So my name is Rushikesh Mayarwade, and I have been working from the last 13 years in the tech industry, and have been gone through different type of technological changes over this past few years. Some of them, like I've been working as a initial tester, performance tester, database tester, performance tuning, all of it. And over like 2017, 18, I found that data was a very big thing. Everyone was working on the data. Even we used to work with a huge amount of data. And I got to see that there are a lot of new type of technologies at that time. The big data was in the boom. Data science was just starting out, but was a very complex topic at that time. Like even there used to be Andrew Ng's course at that time, like that started around 2012, 13. And every year it used to be like, okay, I want to learn this. I used to start and stop. But it used to feel like, okay, it's a math heavy thing. Should we do it or not? We were from a diploma. Like diploma students usually have this one challenge that, okay, you can't, you are not good with math because there's a big gap that you have when you are moving from diploma to engineering. So math is always like a fearful topic for us. But the way we learn maths in the college and the way it is applied in the industry is very different. And maths is very beautiful. Probability, linear algebra, statistics, derivatives, and all those things. When we started in college, it used to feel like just numbers. But in reality, it has a very beautiful applications that we don't value much. But after getting into the data science field, I got to go through all that journey again, and that is good. And like around 17, 18, I did one course by Great Learning that was called Barbie at that time, Business Intelligence, Business Analytics, and Business Intelligence. It was called. So it used to be more R at that time. That was very popular. Python was still catching up. So we completed like 1 year part time in R, and then I was able to move into the field. Like then I got into Morningstar, then I got into Mozilla as well. So those are like some journey that I have been through. They worked on different applications like computer vision, NLP, document processing, and now latest being GenAI agents. We worked on a lot of report summaries, co-pilot agents. Um, so those are like different things we are working on right now. So JNI is a very interesting space. There are so many new things which are happening. So many industries are getting impacted right now. There was just a news today that I read. I forgot about the company name, but one of a company was able to remove 200 HR employees because a good amount of work from those HRs was automated. Maybe they were removed or they were shifted to something different. That is a different thing. But AI agents are able to make a lot of impact right now in the industry, and they have a very good capability. ML, DL, deep learning, and machine learning, all of these technologies earlier had some limited scope. They only used to work with a data heavy kind of problem statement. Not everywhere they were applicable. But GenAI is something that is making changes across the whole industry. Any industry you pick, any domain you pick, there are applications for Gen AI. So that's why this thing is going very fast. Now, within the space, there is this thing called as the agents. And 2025 is being called as a era of agents. I do see some chats. Let me just see that. Devashish, like, are you able to see? Do you see any challenges with these slides and content? Yeah, and somebody said that the audio is not good, guys. Please let me know if you guys face any challenges in terms of the audio. Yeah, please keep posting whenever you face any challenges. Okay, great, great. Thanks a lot. So let's move ahead. Okay, somebody saying audio is too low, guys. Just give me a minute. Let me just quickly check. Okay, mic testing. Are you guys able to hear me now? Is it good? Are you guys able to hear me well? Just one quick check. Great, great. Cool. So let me continue with that. If the audio is good, let's get started. Okay, I like you guys are not seeing anything on the screen, guys. Like everybody not able to see. Left bottom of the screen, there is a option audio setting. Oh, is it like audio? Let me just stop the share and restart it once, and then we can see. Okay, so I would need a reconfirmation again. Is it good now? So are you able to see the screen well? Anything again that you see? Okay, great, great. Okay, guys, like if you're able to see my video, you can just shift it. If the video is something that is giving a challenge, you can shift it, you can move it. That is something you can do. Uh, okay, cool. I'm just keeping the chat. Okay, cool. So let's start. What are AI agents? So AI agents are basically a term that is coming from the world of reinforcement learning. We will talk about the reinforcement learning at a very high level, but AI agent something started with the reinforcement learning where we say that AI agent is anything that can perceive the environment, can make some decisions from that perception, and take an action based on that perception and the decision. It's like right now you are able to see me, you are able to perceive, and then you are able to listen, you can make a decision, and you can talk. Similar to that, we also want the AI agents also to listen to the environment which they are in, then make a decision, and then at the end take some action. So we can take an example where let's say there is a customer agent. Customer agent, the moment he tries to get some kind of a audio from a customer calls with some specific question that, okay, this product is not working for me. So that is a question. Now what will happen is that is a perception. The AI agent is able to see this is a question, but the perception will also involve that, okay, I have a data about this customer, what he bought last time, what are the historic transactions that this customer has, how is this customer usually like calling patterns and all. That is all a perception. He gets all that visibility. Then from all that data, this agent can make some decision. Okay, is this customer like a regular complaining customer? He's like a first time complaining, it's a genuine issue. With this product, are there any kind of a similar type of issues already logged? All of this information the agent will try to analyze and reason after the perception. Then, as the next step, once he understands all this data, he will be able to take a decision. So, this kind of things implementing before the AI agent era was very difficult because all of this data is to some level structured, unstructured, and also complex in nature. But with the AI agents, where they can just understand all things in a very different level, these things have become so simple. So the main part is they can perceive the environment as we discussed, make some decisions and perform actions to achieve certain specific goals. Every agent will have a specific action. Now, as we mentioned, one agent is like a customer analytics agent. One agent could be just an email classification agent. One agent could be a research, um, financial research agent. So there could be like a different type of agents. Every action will have a very specific type of role and goals. They will try to achieve that goal by looking at all the data available through the perception. So that is a core concept which is there. So AI agents are basically defined to simulate how the human intelligence really works. See, when we talk about AI agents, so this word is something very interesting for everybody. AI, artificial intelligence. So the human intelligence is so complex and it is like derived from so many years right now. It has like the things which we are even not able to understand how this intelligence really works. And what we want is this machine to take this intelligence and we creating an artificial intelligence out of it, which is artificial in nature but able to mimic the human intelligence, the way we do the decision making, the way we do the perceiving of the things, talking, language, vision, all of this comes into the intelligence part, and we want the machines to be able to represent the human. Right now, with the AI agents, in many of the things, these machines are able to do similar things as the humans. But it doesn't mean they will be replacing fully the humans, but still humans are required to take lot of decisions out of it, but a good amount of workload is going to be reduced out of it. So that is a core thing. So these agents are designed to do human-like intelligence and enable us to solve some complex problems which were not solvable easily earlier. Like any type of domain, documents, vision, text, tabular data, all of this data is present. But how do we bring all of this together and do some better decision making out of it? That is the goal of this agent. They will have every agent will have a very specific type of role. And the beauty is making them adaptable to the changing situations. Okay, if let's say the agent is making a wrong analysis, we can say that, okay, you are right and wrong. This information can be fed back to the agent, and we say that, okay, next time if this kind of thing happens, you know that, okay, you should not respond in this way, you should respond in something different way. We can also tell it that, okay, this is not a right way to respond, you should respond it in this way. So this type of information we can give it back in the adaptation, and these agents can learn over that time and able to adapt to the given situation. Okay, that's like one of the beauty of it with the seasons. And then learn from the experiences. That is a memory part. Like we give it a memory to learn these experiences from the different interactions. And wherever the agent goes wrong, we try to store it back again so that next time the model knows, okay, how I should be able to handle this kind of situation. Guys, you have any questions, please anytime go on and let me know. I have a different type of queries. Like somebody, Dishant, says that screen is blank for me. Like Dishant, are you able to see the screen now? Uh, do you still feel that same challenge? Okay, only in the pop-up mode. I'm not fully clear with uh, what do you mean by that, but yeah, let me know if you don't see it and more people if facing the same challenge, please guys let me know. Cool. Now, what are the main key characteristics of this AI agent? As we discussed, this agent is going to have first is like a autonomy. What we want is this agent to take its own decisions, like how it can reason and also take some own decisions that, okay, I should do this, and then do this. How do we do this kind of step-by-step reasoning and understand that, okay, this is a wrong thing, I should try again. This is a right thing, I should continue with this. Now there could be branches that, okay, if there are two things available, which one should I pick? So this kind of autonomy is integrated inside the AI agent. We can build that using the better prompting, better tools, different programming constructs. We can build this autonomy in the AI agents. Second is the perception. Perception is all about the overall data that this model has access to. It is the environment. Now, in terms of industry, if we talk about this data could be the document stores you have, like there is a good amount of companies documents present. You have videos, images based data, and like you have charts and everything. Then there is a database that stores all data related to the customers, products, interactions, and everything. So all of this is the perception for the model, right? These AI agents are going to listen to these perceptions when making a decision. Then the important thing is the decision making after getting all of this data. Once it knows that, okay, this is my area of interest, I want to get this information for solving this kind of problem. Now, once I have all this data that is only limited to this type of problem, what decision should I make on top of this data? That is the core decision part of it. Then the learning part out of it. I got the data, I responded, whether the response was accurate or not. This thing can be tracked in a production in a much more efficient way by you may see that in ChatGPT there is a thumbs up, thumbs down options. Then you get to know that okay, this is something right, this is something wrong. Next time we should be improving it. Or in the real world, like if you are interacting with the customer may ask the same question again and again by rephrasing it. So you get to know that okay, the answer that I'm giving is not something right. I should be able to make some more changes to this. This is not working. I should be able to do something different. So this kind of learning we can develop for this AI agent so that they can work in a better way. Okay, so in terms of the history, see, AI as a word has been there from a long time. Like it is from the 1950s, this word has been there when some scientists sat together and decided in a conference that, okay, let's try to work and build something for artificial intelligence. How do we automate what humans are doing? At that time in 1950s, the definition of AI was very simple. It was even like building some simple rules that can automate the human efforts. Even like building some simple calculators with some number addition, multiplication, division. Even that was like a AI because the systems were very simple at that point. And over the time, this AI definition has been changing by a good margin. So there was a Turing test by Alan Turing, which says that, okay, how do we create a system? Okay, does anybody know what is Alan Turing test? Can somebody put it over the chat? Let's see, like how many, you know. So does anybody know here what is the Alan Turing test? Select the best alternative out of two. Okay, Mayank, good try. Okay, great, guys. Thanks for the response. Cool. Let me talk about it. So there is a great scientist called as Alan Turing. He said that any system, if let's say there are two people, there are two people sitting in the room beside me, and they're talking with each other. One of them is a AI agent, and one of them is a real person. I'm standing here behind the wall, and those two are talking. I am not able to differentiate between who is agent and who is human. I can feel that as both of them being same. That is a Alan Turing test. That the system passes the Alan Turing if the human is not able to distinguish between the human and the AI agent. And right now, we are able to see that the current systems are able to breach. Like it took so many years. That it started in 1950s to 60, but almost like from the last 2 years, we are able to see this distinction that the models now can be very realistic in terms of the audio. That we can't distinguish that okay, this is a uh, real audio or machine generated audio. There are now even very good tools which can mimic your audio as it is, not just your audio, but even it can represent you as a video very well that you even won't be able to differentiate that okay, this is me generated as an avatar. Audio cloning, video cloning, all those things are there, but you have a very good AI systems which do this. So symbolic AI by John McCarthy. So all this tests they started at that point. So then there was this era of rule-based decision making, like development of this expert system, which were deterministic in nature, like rule-based systems, because at that time this machines were very simple in nature, but there was a learning capacity. These models just used to be hard-coded with specific rules that okay, this is what you should get as an input. If put this rules, and then give it as a output. That was a simple structures. Then from the 1990s, people started to work on the machine learning. This machine learning traditional models like the linear regression, logistic regression, simple decision trees. Based on this type of models, the machine was able to learn from the data. The core of machine learning is how do we learn from the data? The history. See, we as a humans learn based on our experiences from the past. And what we call experiences is nothing but the data that we have gathered across our experiences. That okay, if we do this, this works. If we do this doesn't work. Like, this is the experience that we have gathered. In the same way, in machine learning, the model tries to go through the past data and learns the patterns, and it can make a prediction for the future. So around this era, there were different systems like neural networks, reinforcement learning, simple models, all those things were there. But these things were not very good at this point because there were two different challenges. One was the quality of data. Second was the compute. The compute was still getting good, and the quality of the data was also not that good at that point. So these systems were not able to scale that well. From 2000s to 2010, there was a big boom around big data technologies. So with the big data, companies started to see that, okay, there is a value in the data. Should we start storing this data and do some simple analytics out of it? So at that time, there was nothing much about machine learning and all, but just people wanted to bring this historic data and do some MIS analytics and bring some value out of those data. So companies started to store a lot of data. Then around 2010, after that, what really happened is there was a good progress in the compute. The CPUs, GPUs, all of that had a very good progress. And then companies were also storing data. Then the machine learning, deep learning, all of these things, people again started with this new data and compute. And there was a big boom. Like people were able to create some very good models which were able to learn from this complex data that was getting stored. So deep learning got a very good popularity from 2010. Deep learning is nothing but neural network based systems which are based on the human neural networks, but it took a very different trajectory after they started with the concept of human brain, but it took a very different trajectory after that. So after 2010, there started a good progress around the different models, a good progress around computer vision, natural language processing. There are different models like convolutional neural network, artificial neural network, LSTM, RNN. These are like different type of deep learning models that people started to explore and get a good output from it. Okay, and then just to add, after that, there is also in 2016, there is a big paper called as Attention is All You Need Transformers. I don't know how many of you heard of it. Um, but that paper made a big impact in the overall industry of artificial intelligence because with the with the attention and transformer based models, it was possible that you can keep on feeding it a large amount of data, and this model will keep learning this whole data. So all this GPT, the generative pre-trained transformers, this all the new age models, the Gemini, Llama, Mixtral. Anybody knows anything beyond this? I talked about three GPT, Llama, Mixtral. Do you guys know any other models which are there? Any other models that you know of other than okay, Hafiz Safety, that's very good, good. Claude, Anaconda won't be a model. That is the Python environment, but a good try, Pooja. Very well. But yes, a very early model, first model in this whole life cycle. Tarun, yes, OpenAI is for the GPT. Good. Pooja again, NumPy is something that is for data processing. But a good try. Keep on doing it. That's great. Grok, yes, Grok is from the Elon Musk, a different model that he started, Gemini, DeepSeek. Very well, guys. That's a very good list that you guys have. Good. So all of these are like different type of models that people and companies started to train, and we have this large models which are like which can take hundreds of GBs of space to load. Okay, you can imagine like it takes hundreds of GBs of space to just load inside a GPU, and these GPUs are very costly in nature. But these big companies are able to deploy these models, and we are able to access these models as an API. So for a general purpose use cases, we try to access this as APIs and use it. And for a company which needs everything to be private, they try to host these models internally and then utilize it. Okay, so that's a key trend which brought us to the Gen AI era, where it is about generative AI. These models are capable of generating things, right? You see a text generation, you see image generation, there's an audio generation. There is a video generation. So so many type of generations can happen. Like you are giving it a one type of information, and then it is able to fill that, generate it. When you try to prompt something on the chat GPT, whatever the question you put, the model just tries to make a prediction for the next possible word. These models are also called as the next word predictors. You see that, okay, one word is getting populated. What really is happening is it takes this input, makes a prediction for a one word. Then it takes again the whole context with this new word, again makes a prediction for the next word. Again, this new word is added to the input to make a prediction for the next word. Like this, it keeps on making a prediction for the next words, and you get output. That's why it is called as a generative AI. Same way in images, it is trying to generate and all. But yeah, that is a background structure to it. Now about AI agents. So we talked that okay, these AI agents are just making a lot of trends in the industry. A simple example could be, let's say you have a stock trading agent. The stock trading agent can have a perception, right? For this agent, the perception would be the news, the technical data, the fundamental data about the company, that okay, how these companies are performing and all, what is happening in the market. So all of that can work as a perception to this model. And now when you ask it about a certain company that okay, how this company is going to perform, if agents can look at the perception, all the data that it has available, make a decision and provide an action that, okay, see, this is how this company can perform. It could be like but not a very high level analytics, but still to a simple level, you can get a lot more better output from it. Like this, there could also be multiple agents working together. We call it a multi-agent architecture, right? Like one agent is just generating the research based on the data available. One agent can do a internet search. One agent can trade for you. Okay, like the multiple agents can communicate with each other with a different roles. What we discussed in the starters, every agent will have a very specific role. Okay, it will not have a lot of responsibilities. Every agent will have a very specific responsibility and the goals. So each of them will have a different responsibility and they'll be very good in that responsibility. They'll only work on that, but will be good in that responsibility. Okay, so automation is the very important thing that we are looking for through this AI agent. So AI agents can handle repetitive, time-consuming tasks, allow human workers to focus more on the strategic thing, but the mundane, repetitive things can be automated using the AI agents. Scalability, if one person can work on this thing, but now once this AI agents can work on this, you can imagine now, for example, just to talk about again this talk with the domain being I'm in, if there is one research agent in a company who goes through all the company reports, understands about that company, he takes like weeks to just go through some companies. You can imagine if we try to create an AI agent that can replicate some level of efforts from that uh, person, we can create thousands of AI agents. And these thousands of AI agents can keep crunching the data. And then we try to give a summarized information to this research person. And he can work on a pretty good analysis. And on top of it, he only has to work on something that is more interesting and something insightful rather than he working on everything by himself. So that's the beauty of scalability. There is a question. So let me see. Is that because of the LLM context window agent segregation? It's not just because of the LLM context window. See, what really happens is, Dishan, in the prompt engineering, what we say is your prompt should have a very good role defined. See, these models, if you try to, like even in ChatGPT prompting, a best practice is you should add a role. You should always provide this context saying that, okay, you are a marketing specialist, you are a teacher, you are an expert programmer. So you try to provide this role so that your model will respond in a very similar way. But if you don't provide it, this model will work like a average person. It will not work like an expert in that domain. So you have to give this role so that it can work much better in that area. So here also in the agent also to make it very accurate in that work, we try to give it a very specific role and segregate them so that there is not much of a confusion. See, if you leave the models in an average way, these models can just give you anything, any random garbage, they can hallucinate, they can create all those challenges. That's why we try to limit them. Okay, I hope you are able to get me, Dishan. Okay, so real-time decision making, this becomes a complex. Let me go through Dishan's. But just a trading agent can be clubbed with a research agent, as trading agent should just place trade. Yeah, absolutely, Dishan. See, it's the design that we can create by ourselves. Like, okay, what is the complexity we want to add? Complexity can vary. When you get into the real data part, if you just go with the trading agent, there could be a buy side trading agent, there could be a sell side trading agent, there could be just an online research agent. Because if you try to create a one single research agent who can do internet search, who can do PDF search, who can do technical, it will do a mess. So you have to separate all of them so that they can work in a very specific manner. Okay, that's why we create this multiple agents. Okay, so real-time decision making, that is like a very important thing, like in a customer analytics use case that we discussed. If a customer is talking, you can't have that customer waiting for like 5 minutes. You have to provide the response in a much faster way. That's why the real-time analytics plays a very important role. Adaptability, like if the models, see the way we humans are, even we humans are never 100% accurate. We also have a certain level of percentage of accuracy. Even like whatever expert we are in certain field, we will also be making mistake. So even with the models, we expect that they will be making a mistake. Now if the mistake is coming, but how do we learn from those mistakes? Because we humans also try to keep learning from our mistakes. So this models also we try to adapt them by adding a learning layer where whenever there are challenges in terms of the output, we are able to feed it back as a feedback, and then model should be able to cater to that in the next iteration. Personalization. In a world currently we are in, everything is personalized. Like you go with the Instagram, you will have a reels which are very different from the person that you're sitting with. Okay, like everybody will have a very different type of personalization. You go to Amazon, your landing page versus other person's landing page will be very different. So the personalization plays a very important role, and LLMs can over the time help create a very personalized systems in every area. It could be like learning, it could be your buying experience, it could be a lot more things like your healthcare experience. All of this would be very personalized to the LLM. It can understand the customer behavior, customer past transactions. It can just analyze everything and give a very personalized responses. Great. So the important things here, as we went through the examples for this, the first part is the core component is the perception. It's all about data. Okay, when we are creating the industry applications with AI agents, if there is no data layer, agents are nothing. It's just like you're prompting on the query with the existing knowledge. But what a model has as an internal knowledge is not enough for us, right? That can just purely work with the traditional prompt engineering. But AI agents plays a very important role when they have to go beyond the LLM. Like whatever is there in the LLM's learning, we want to go beyond, access the outside world, learn from it, get the data, whatever is required, and then how do we process it? So perception as what is visible to this AI agent plays a very important role. Now, internet searching agent, the internet research agent will only have access to the internet. Okay, he will not have access to the database and everything. The internet agent will only have access to the internet. Uh, a customer analytics agent can only have access to customer analytics tables. He will not have access to the whole DB. If we just those specific customer tables, he will have access to. Like this agent will have a visibility in the different type of data. Then The reasoning part, this question that comes in, the model should be able to break this question into multiple parts, like steps. You will see that the reasoning model, there are like O3 and all this like deep seek reasoning. You will see a lot of reasoning model. What the reasoning model do is they try to convert your given problem into multiple steps, and then based on those steps, they try to take action. So that is like a reasoning step. Okay, I got a question. Now, how should I solve it? Okay, like for example, if you try to ask it a multiplication of a very big number, the model may perform well or may not perform well. But through the reasoning, it can do actual calculation and then give you the response. So, like that, reasoning plays a very important role. So, you got a perception of the data based on the question. You identify what is the relevant data from the perception, you take it, you reason on that data, okay, and then you take action. Let's take an example that okay, there is a user. We want to define whether the user we should give the loan or not. So in this case, the agent will have access to the customer's history. What is the CIBIL score? What is the age? Where he lives in? What is the job? Salaried, not salaried. So those kind of information we will have access to. This model, based on the question coming where customer's data, will reason through it that okay, based on this history, we should the reasoning action step is whether we should give the loan or not. The reasoning step is trying to understand the overall data. And at the end, learning. If the model is making a mistakes over the time, the learning will be added back to this model for a better outcome in the next time. Any questions till now, guys? We have talked a lot of things, uh, but please let me know if you have any specific questions from whatever we went through. Learning is part of LLM fine tuning or something else? Okay, that's a very good question, Dishan. There are multiple ways by which learning can be incorporated in the LLM. So one is a model fine tuning. Second is a context fine tuning. And then there are like more of, so these are the two major ones. In one, you try to actually change the neuron weights, whatever the model has learned, we try to like change internally by incorporating our domain data. Second is a context fine tuning. Context fine tuning is whatever the knowledge we have, we pass this knowledge as a prompt input. Okay, like you have a company document. Now the models like have a very good context space. Earlier the context space was very less. It used to be only with a very initial model like 3, 3.5 and all. It used to be like 4,000 words you can pass. But now the Gemini 4.1, all of those can take 1 million words as an input and then answer a question. So whatever the information you have, you pass it as an input, then add a question. So this becomes a context fine tuning. So the knowledge that the model didn't have, you try to provide it explicitly and then ask a question. Majority go with the context fine tuning because LLM fine tuning is slightly costly. Like you fine tune the actual model to the deeper level, that is costly. So that happens in rare cases. But the second thing is done in a very common way. Nishant, I hope that answers your question. Great, great. Cool guys. So any other questions, please keep shooting it. That will be great. How is agentic AI different from normal AI? Okay, that's a very good question, Mayank. See, AI is a very broad term. Okay, AI, as we discussed, talks about how do we create a intelligence of a human in the machines, like we created artificially. So that is like a very theoretical topic. Within AI, we have multiple techniques. Okay, so AI as a theoretical umbrella has a lot of things. So machine learning falls under that, deep learning falls under that, and now new thing which is a agentic AI also falls under that. So agentic AI specifically focuses on creating this very specialized agents which have access to certain data. They can reason through it and provide the answers. So that is the agentic AI. Previously, before to the agentic AI, we used to call AI for the deep learning models. These deep learning models were very specialized in computer vision, natural language processing, audio processing. So these models were very specialized in this application. We used to call them AI-based models. But now the AI has shifted to the agentic AI. As I told, the definition of AI keeps on changing over the future. At the start, it was a very simple rule-based thing. Now it has come to a phase where this AI agents can do some autonomous things. Okay, I hope that clarifies your question, ma'am. If any question, let me know. Great. So we need to learn Python if I'm developer for AI. Okay, that's a good question. See, Python has a, a very good frameworks and everything present to build these systems. Other languages also have it, like Java, .NET, they also have it. But Python has made it very simple. So learning Python can absolutely help you build this AI applications because still I would say 90% of the applications in the agentic space would be built using the Python. Okay, so Python plays a very important role in the AI development. But it just doesn't have to be if you're still good with like Node, Java, .NET. Even within that, there are libraries available which you can utilize and build the AI application. So that is feasible. Okay, so do AI agents reflect the future of SAP functional module? Okay, so Gangesh, I may not have a very good background in the SAP, so I won't know what is the SAP functional module. But if you can just give me a brief, I may be able to help you with that. Okay, like I can tell you maybe AI didn't reflect something in that or not. If you can give me a small brief. So Visali asks, can AI agents be reused across multiple AI tools? Okay, that's a very good question. See, building this AI agents, like once we build this agent, it can be easily reused in another spaces. Okay, as I said, right now, okay, there is a research agent. Now there is one internet research agent we have. Now this agent stack is to do finance research. Now if maybe the similar thing we want to use in the marketing to research about the competitors, then a marketing agent pipeline can also reuse these agents to understand more about the company through the internet. So reusability because these are nothing but tools. So this code from one place can be again reused in a another place and we can do the reuse part. So that's possible. But now when you talk about tools, it will depend. If you're talking about pure tools, so tool to tool checking, like if Python as a code tool you're saying, that is possible. But if you talk about something different, that is slightly tough yet. But there are many frameworks coming up. You may have heard about MCP, Google A2A, those are things which are coming up. So A2A says that, okay, there's a new protocol agent to agent. So agent built at one place can communicate with the agent built in another complete remote place. Doesn't have to be same language. It could be any different language, any different tool, but they can communicate with each other through the protocol. So those are the things still in a very early progress right now. How AI agents learn and improve their performance. For example, I have an agent that interacts with customers in real time. How and what will the agent improve? See, if your agent is interacting with the customer and the response that this agent is giving to the customer is not accepted, maybe customer is not happy with the response. So how the systems are built is you always have a feedback mechanism where you try to see whether the user liked it or not. Even with the human agents, you have this feedback mechanism. At the end, this human agent will say that, sir, after this call, there will be a feedback thing, you give me a feedback. So same way, you can gather a feedback from for this AI agent thing. And with the feedback to say that, okay, whatever responses you gave, those have some issues, next time try to improve it. If you try to do this kind of thing, this models will be able to improve next time with some better responses. So these are like some simple things that you can do. You will not be seeing a very big change in the output, but model will not do the same thing that it did last time. It will try to do something in a different way. Now again, you got a one more feedback that okay, if this new thing is also not good, even this will be added back to the model. So now next time it knows that okay, whatever I did last 2 times, I should still do something different. So, just to give a very simple example, I hope everybody has played games. One of a simple game could be Mario. Now, what will happen is when you start this game for a very first time, okay, you're starting this game for a very first time, and you start, you don't know what is going to happen. Okay, you don't know about the game. So, do you know what is the first thing that comes in the Mario game? Whoever has played that, like what is the first thing that you see coming? Anybody knows here? The game fans. I would think that everybody must have played in their childhood Mario. Okay, so I got two different answers. Somebody said the duck, and somebody said mushroom. Okay, again, one more person said duck. Okay, good. So, if let's say mushroom or duck that is coming, okay, but there is no duck. I would say there is a mushroom is there from the pipe, but you will have first coming as a turtle. Okay, when you start, you will see a turtle, but you jump on the turtle. But at the first time, you don't know. You just go closer to the turtle and stop, or maybe you just collide with that. You may think that okay, this is a good thing because you don't know what will happen. So first time, the character may die, and your game will start again. What will happen is you got a memory saying that this is not to be done next time. I should be doing something different than touching that. So you may try to jump next time. Now you know that okay, this is the right thing to do. Again, you go next, you get a new obstacle. It could be a pillar, it could be a mushroom, or it could be anything. And then you get to know that okay, now how do I interact with it? You again maybe dump into it, collide with it, and then get to know that okay, this is not to be done. So this is a learning that you build over the time. Okay, so now you keep building this learning, you keep adding it to the model. Okay, this is the question was you gave this response, so this is not good, next time improve on it. So this kind of memory we keep adding to the model over the time, and then the model starts improving via small margins. Okay, there are a lot more things we have to do to create a production grade system through this, but this is a high level idea, I would say. Okay, Maya, good to know that you're able to get something there. Great. Any other questions before we move on? Cool. So thanks a lot for the great question, guys. That's a good discussion. Let's move on. Now there could be like different type of agents. One is like a very simple reflex agent. These are like very simple rule-based, predefined responses, predefined rules kind of agents. Not much of a memory, not much of a smartness, but these are like simple agents. Next is a model-based reflex agent. These have some internal learning from the previous data. They, rather than just going with the plain rule-based thing, we have learned some relationship. We have some learning about the data. We know that, okay, if this comes, this is what happened in the future by this probability. If this input comes, this is the output based on the history. So this model tries to learn from the history and then make a response. So slightly smarter than the simplex one. Then there is a goal-based agents. They have a very simple goal. The desired outcome till it is achieved, this model will keep on responding. Okay, like you give a response, you say that if it is matches the goal, if no, you again try to generate a response. If it matches the goal or not, you again try to generate. Like this, it's all about the goal. Then you have a utility-based agents, like based on the different actions. Like you may have a multiple actions for a given input, then you have to define what will give me the most better output. Like for example, a chess game. You may know that, okay, as a next step to this thing, I can even move this, I can move this, I can move this, multiple things I can move. But what should I move that will give me the best possible utility? That is the utility based agents. And then the learning agents. These can learn based on the responses that they're giving. Okay. The real world applications would be a mix of those different type of agents. It doesn't have to be just a one type of agents or these are like an improved version from one to other. There could be applications where you just need a very simple agent. There could be agent which will require a goal-based thing, learning agent, or one agent could have a lot of different things combined. An agent could have a learning and goal both together. So the agents can have a complexity involved within that. There are different ML-based approaches, supervised learning, unsupervised learning, reinforcement learning. These are traditional ML-based algorithms. So any machine learning-based problem statement can be segregated into this three different categories. One is supervised learning, where you know what is expected. Okay, just an example. Uh, you know that, okay, given a customers details that we just now talked about, the credit scoring, the customers data, you have it. You know whether the loan should be given to this person or not from the 10 years of history. A bank has a 10 years of history and knows that, okay, based on the features of the user, we should give the loan or not. So we know what is expected based on what type of input. So model will try to learn the relationship between the inputs of a user and whether that user actually paid the loan in the future or not. Now, whenever a new user comes in, we have got some learning from the history. Based on only the input, model will be able to decide whether to give this person loan or not. This is a simple supervised learning example. There are different models to treat with this. Unsupervised, we do not have any kind of specific output that we want to achieve. It could be anomaly detection, clustering of a data, just a data compression, so lot of different things, but there is no specific thing. Anything that is not supervised in machine learning is unsupervised. Reinforcement learning, the Mario game that I talked about, is a very good example of reinforcement learning, where based on the environment, we keep learning what type of best possible action to take. Best examples like the LLM models are also fine-tuned with supervised learning and reinforcement learning together to get a better output. General strategy for any model implementation is we first collect the data. Whatever the data in the raw form, it could be unstructured, structured. We collect the data, we process it because every machine learning algorithm requires the input to be in the numeric format. Okay, all of these are like number crunching machines. So any input, we have to format it to a number based system. There are different strategies to do that. Once it is in the form of numbers, we try to train the model on this number. As I say, these models are nothing but number crunching machines. Then once we have it, we deploy it in the productions where input would be given, output would be coming from this model and shared it with the user or downstream application, upstream application. We can do deployment in a different ways. At the end, monitoring and the maintenance. Monitoring says that, okay, whether the model is performing the same way it was trained on, whether the model's performance has degraded over the time, it is good. Do we need a retraining of the model? Are there any kind of specific issues, data level issues? So lot of monitoring happens, maintenance happens in the model. So this is like a very high level helicopter view of what is the general um, implementation pipeline looks like. Okay, so AI agents, we have discussed the different use cases. One is the autonomous vehicles. We have robotics, robots. Robots are nothing but like a individual agents that can perform different types of tasks. Personal assistants that we all recently use, this chatbot and all, this ChatGPT and everything is nothing but like everybody's personal assistants right now. And then the game. Games, every character is like an agent, okay, within games. So the future games are going to more complex. The enemies that we see, right, in the games usually are given a very fixed role. But now, over the future, these enemies can also be agents, can very well play as a real human from the front without anybody really being there, rather than the rules, they can play very well with the proper decision making. Financial trading, I gave a very good example. Healthcare, like for the treatment of the patient, based on all the history, medical equipments available, medicines available. How do we give a very personalized recommendation, monitoring, disease diagnostics, and everything to a customer or a patient? Healthcare is a very important area that AI agents are trying to work on. Okay, so that was about the overall AI agents. But this is a great learning program, which is a so great learning is one of the big tech for providing professional higher education. So many learners have learned across the country about different topics of the AI, ML, security, other spaces. So ranked the number four on the MS. It's a 12-month program, have a very flexible structure, and you will be able to get certification from Great Lakes, UT Austin, and ranked number one for last 5 years. Has a peer-to-peer learning. You have immersive experiential hands-on faculty who have a very different experience from different domains and a vast number of years. You will have a prep courses for Python, GenAI, basics of maths and everything before you get started with the actual curriculum. Exposure to different type of important tools, domain exposures, and different type of tools. Okay, great. So if you have any questions, please connect with the team who is here. You will get a form. If you want to get connected, want to know more, please connect with the team. So let me now check. I see there are some questions. Let me just go through the questions now. Okay. So how do you integrate the model with the product design? How do you performance test the AI models and robots? Okay. Uh, so that's a very good question, Mohammed. So what really happens is you can imagine this to be a see like ChatGPT. ChatGPT is giving you the responses. It's an input and output. You gave it an input, you gave it output. So that's a product. Now, product can be designed in a very different ways. Like see, this LLM based applications can have a variety of output. You can return images as output, you can return text as output, JSON as the output, code as the output, video as the output, audio as the output. Now, you have to decide what is the requirement of your application. How is this input and output the application is going to showcase and use? For example, the trading bot example that I mentioned about, this here doesn't have even any like front end. Would just show that okay, this is a stock, this many trades we did, this is the performance or price or appreciation we got in the trade. So you will have a UI that will just show all that. But in the background, this AI agents are doing a number crunching and doing some actions. Okay. It could be like customer analytics agent. Here, it will be a mix of audio, text to speech, speech to text, LLM models working, and you're trying to see a whole end-to-end pipeline, you may test all of them separately. So in the product, it's not just a very simple question to answer, but again, it depends on how you're designing the application and how the input is going to be consumed, how the output is going to be consumed. So it will all depend based on those factors. Okay, it's a very generic answer I'm giving, but frankly, this models have a very varied output structure. So you have to define like what will be the input, what will be the output. Performance testing, yes, can be done easily because this can be hosted as APIs, and you can just performance test these APIs and observe how the responses are coming, how the hardware is behaving, how the scaling is behaving. You can just test all of it. Can I get your input on future growth of AI development versus data science domains, both in Indian and global market? Okay, Srinu, that's a very difficult question, I would say. This industry is growing in a so fast manner. We can't very well say that, okay, how this industry is going to grow. But yes, absolutely, the data and data science are going to be the core skills. Okay, because data is always very complex. The domain knowledge plays a very important role when we're building the data science based application. So not everything is right now understood very well with this LLM models. LLM models can do a good work of initial data science work, but a human effort is still required to a good extent in building the data science application. I can just say that till next 3 to 4 years, this field is going to be very much in the boom. Okay, 3 to 4 years, this field is going to be very much booming based on the history and trend that I have seen till now. And even like 7 to 8, 10 years is going to be still a big thing for the data space. Okay, and both Indian and global markets, absolutely. It's going to be making a big impact. AI specifically is going to be staying for a good amount of time. It's still, I would say, very initial phases where we are working on the AI. Lot more progress and update is still required. The systems are not stable. In terms of stability, there is still a lot of work needs to be done. Because of this instability, a lot of coding work goes on right now. So for over like at least 4 5 years, there's going to be a good work going to happen in this space. Okay, what is meant by evals? So, Dishan, evals is the evaluation. Like, how do we evaluate the systems? Okay, so evaluation is a bit difficult with the systems. Like it's not a 1 0 or a number based output when you say that the expected was 10 and what we got is 9. You say that okay, 10 minus 9 is 1, so lag by 1. So we can't straightforward say that. It's more of this is a text input we expected, like this is a text output we expected, this is the text output we got. In terms of meaning, are they really similar? Are they different? The words can be phrased in a very different way, but how do we compare both of these sentences and say that okay, model is able to generate a very valid output in terms of evaluation? So that is a space that is still in a growth, but a lot more progress has happened in that. Like how do we compare this textual outputs and say that okay, this model is doing good? Okay. Can we simulate 1,000 concurrent user loop to test the model? Absolutely, member. Like it's again a system that you are developing, which will be deployed, which will be working, deployed. You will be able to do a concurrent load test and see how the systems are behaving. Are they able to take the load? If you're deploying your own custom model, is the model able to scale across the multiple systems? If you're using a Kubernetes and all, is the system scalable, growing based on the user load, how it is growing? So all of those things you can absolutely test. Okay, great. I think with that, the questions end is what I see. But pretty good question, guys. This was a great discussion. I hope it was helpful to you all in terms of the knowledge. Okay, what are the ways the models share knowledge? Okay, uh, agents. What are the ways the see? It's a as I said, they can share the knowledge and outputs in a very different ways. These are called as a modalities. Textual output, JSON-based output, HTML-based output, Markdown-based output, image-based output. Like it can give the output in every possible way right now. We have to define what is the application we are building and how do we want the systems to work, and then they can integrate it in the systems. Okay, but there is no limitation that what type of output the systems can generate. Okay, great guys. Thanks a lot everyone for being here. Okay, I hope you all liked it, and I hope it was able to solve many of your questions around the AI agents. Okay, but thanks a lot everyone for being here. Take care. Have a good time.
Hi everyone. I'll just wait for a couple more minutes. Please take a moment to fill the feedback form shared. Copy the link. You can drop the call. Please copy the link and then fill the feedback form. Thank you. Well, thank you so much, everyone. Have a great weekend.